All right, similar figures are just figures that are basically the same shape, but not necessarily the same size. Okay, and we use this tilde symbol in order to indicate that figures are similar. And so again, if you think about like when things are drawn to scale, like a blueprint of a house, that idea is that blueprint is supposed to be drawn exactly the way the house is built, but it's drawn in a really, really small way, or like a model car or a model train or something like that. It's meant to be identical in every way except for the size of the thing, all right? That's what we're talking about when we talk about similar figures, all right? We still have to name them just like we did with our congruent figures. We still have to name them by corresponding pieces. And so when we look at like this one, I would say that, hey, A, B, C, D is similar to, well, I have to match up the pieces that essentially look the same, just have different sizes. And so when I look at that, this guy is going to be W, X, Y, and Z. And I can't label it any other way because in terms of drawing this thing, notice I have like the shortest side here and the shortest side here. And so I have to match those up in terms of my name, just like I did with congruent figures. The only difference is now we're not looking for these things to be the same. We're going to look for these things to be proportional. Okay? And so I still have to match them up the same way in terms of labeling things, but now I'm matching up the sides that correspond in terms of being proportional, in terms of being the same side but for the smaller thing, or the same side but for the larger figure. So some of the things we look for with similar polygons are basically two polygons that are similar. And we know that things are similar if there's two things that have to happen. The angles have to be congruent. So the angles will be identical because that deals with the shape, okay? So the angles make the shapes the same. And that's what we're looking for with similar figures. Same shape, different size. Angles make the same shape. So when the angles are the same, the shapes are the same. But then the lengths of the corresponding sides are proportional. So they're not the same size. They're different sizes, but they all have the same ratio in terms of comparing each side. Okay? And so if I look at something like this guy, the idea here is that the angles are the same. So the angles being the same makes the shapes the same. So in this one, angle A would be congruent to angle W. Okay? Angle B would be congruent to angle X. Angle C would be congruent to angle Y. And angle D would be congruent to angle Z. Okay? That's the idea here, that all the angles are exactly the same because that gives us the same shape. But now when we compare these, the sizes are different, but it should be proportional. In other words, if I compare the length of AB, so the length of AB, and I compare it to the smaller figure, which would have a length of WX, if I compare those two sides and write a ratio comparing those two sides, in other words, like if this was a 5 and this was a 3, the ratio would be 5/3 the way I have it written, okay? But that should be the same no matter which sides I compare. In other words, if I compare sides AB and WX, I should get the same ratio as if I compare sides BC and XY. Okay? I should get the same ratio as if I compare sides CD and YZ. I should get the same ratio if I compare sides AD and WZ. Okay? And so if we kind of go back to that same example that I just said, like, hey, if this is a 5 and this is a 3, well, then it would be okay for like this side to be a 10 and this side to be a 6. Okay? Because notice the ratios are the same here. 5/3 is just 5/3. But then looking at these other ones, 10/6 is still 5/3. That idea of proportionality, in other words, when I compare the different sides, I still get the same ratio. That's what it means to be a similar figure, okay? Identical or congruent angles, because that makes the shapes the same, but then proportional sides, which makes the sides different, but they should be proportional.